Assalamualaikum. My name is Mustaqim. So I will present about our project that is hotel booking demand analysis and booking cancellation prediction. The main objective of this project is to analyze hotel booking pattern, identify factors that influence booking cancellation, and develop machine learning model to predict whether booking will be cancelled. The dataset used in this project is the hotel booking demand dataset, which contain booking information from both resort hotel and city hotels. The dataset include various attributes such as lead time, customer type, market segment, average daily rate, booking status, and many others. Before conduct the analysis, we perform data cleaning and processing. First, we check for missing values and handle them appropriately. Missing values in columns such as children, country, agent, and company were filled using suitable techniques to ensure data quality. Next, we check and remove duplicate record to avoid biased result during the analysis. We also perform feature engineering by creating several new variables, including total guest, total night stay, and total booking costs. These new features help provide better insight and improve the performance of our machine learning models. After completing the data preparation process, the dataset was ready for exploratory data analysis and predictive modeling. That's all from me. I will pass to my teammate. Thank you.
Okay, now we move into the exploratory data analysis section, or EDA for short. My name is Ahmad Aslam Mubarak bin Aswan, ID number 5222422435. The first thing we did here was check the shape and structure of our clean dataset. As you can see, after pre-processing, our dataset now has 87,377 rows and 35 columns. We also printed out all the columns names so we know exactly what features we're working with, including some new ones we engineered earlier like total guests, total nights, and total costs. Now we visualize them. The distribution of our target variable is cancelled. This count plot shows us how many bookings were cancelled versus not cancelled. This gives us a quick visual sense of the class balance in our datasets. To put exact numbers to the chart, we calculated the cancellation rate as a percentage. The result shows that around 72.5% of bookings were not cancelled, while 27.5% were cancelled. This tells us the dataset is somewhat imbalanced, with more non-cancellations than cancellations. We then look at the distribution of hotel types using a donut chart. This shows the proportion of bookings between city hotels and resort hotels, giving us a sense of which hotel type is more popular in our dataset. Building on that, we compared hotel type against cancellation status using a group bar chart. This lets us see whether city hotels or resort hotels tend to have more cancellations, which can reveal important business patterns. Here we plotted a line chart of monthly booking trends across the year. We reordered the months chronologically from January to December to make the trend readable. This helps us identify which months are the busiest for hotel bookings. We also explored the lead time distribution, that is how far in advance guests are making their bookings. The histogram with a KDE curve shows that most bookings are made within a short lead time, but there is a long tail of bookings made months in advance. Similarly, we look at the distribution of average daily rate or ADR, which represents how much guests are charged per night on average. The histogram shows the spread of pricing across all bookings. We then identified the top 10 countries that generated the most bookings using a lollipop chart. This gives us a geographical breakdown of where our hotel guests are coming from. Next, we visualize the distribution of market segments such as online travel agents, direct, corporate, and so on. This area chart helps us understand which booking channels are most commonly used. We also looked at deposit type distribution using a donut chart. This shows us how many bookings were made with no deposit, or a non-refundable deposit, or a refundable deposit. Here we explored customer types using a lollipop chart. This tells us whether bookings were made by transient customers, contract customers, group or transient party customers. To compare pricing between hotel types, we use a box plot of ADR by hotel type, which first filtered out the top 1% of extreme ADR values to avoid skewing the chart. The result shows us the typical price range for city hotels versus resort hotels. We then looked at how long guests typically stay by plotting the distribution of total nights, which most guests tend to stay for a short duration, with the frequency dropping as the number nights increases. We created a new feature called Is Family, which classifies bookings with more than two guests as family bookings. The count plot here shows the split between family and non-family guests in our datasets. This group bar chart examines the real relationship between deposit type and cancellation. It reveals an interesting pattern. Bookings with a non-refundable deposit actually have a higher cancellation rate, which is counterintuitive, but an important finding. We also check how many guests are returning visitors versus first time guests using a horizontal bar chart. The result shows that the vast majority of bookings come from new guests. Here we look at which distribution channels are used to make bookings, for example, through travel agents directly or via GDS. This lollipop chart gives us a clear ranking of the most commonly used booking channels. We then computed the cancellation rate for each hotel type. City hotels have a cancellation rate of around 30%, while resort hotels are slightly lower at about 23.5%. This confirms that city hotels face a higher risk of cancellations. Next, we group total revenue by month to see which months bring in the most income. The results are sorted in descending order, so we can quickly identify the highest revenue month. We also calculated the average total night stay per hotel type. Resort hotels have a longer average stay, about 4.4 nights, compared to city hotels at around 3.1 nights, which makes sense given the nature of resort travel. We then look at which market segments generate the most revenue. This helps identify the most profitable customer groups for the hotel business. At this point, we summarize all the key findings from our EDA, which we identified cancellation patterns, booking trends, pricing behavior, customer types, and revenue opportunities, all of which will guide our machine learning model. So this is basic. Now we move into data preparation for machine learning. We started by selecting all numerical features from the dataset and printed them out so we know which columns will go into our correlation analysis. We computed a correlation matrix for all numerical features and visualized it as a heat map. This allows us to see how strongly each feature is related to the others. Using a color scale where red indicates positive correlation and blue indicates negative correlation. We then specifically extracted the correlation of each feature which with is cancelled and sorted them. The bar chart shows the top features that have the strongest influence on whether a booking gets cancelled or not. So that is basically for my part. I will be passing this presentation to my next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Haikal bin Zailan, and today I want to present machine learning preparation. My part is the machine learning preparation, where we prepare the dataset before training the machine learning models. First, we create a copy of clean dataset using a df.copy. This ensures that the original dataset remains unchanged during the machine learning preparation process. Next, we remove the column and reservation status date. This column were excluded because they could reveal information about the final booking outcome and potentially cause data leakage, which will affect the model fairness and accuracy. After that, we identify all categorical variables such as hotel types, meal type, country, market segment, distribution channel, deposit type, customer type, and family status. Since machine learning algorithm cannot work directly with text data, we use label encoding to convert these categorical values into numerical values. Then we separate the dataset into X, which is features, which contain all input variable, and Y, target variable, which is cancelled and indicate whether a booking was cancelled or not. The dataset was then split into 80% training data and 20% testing data using train test split. The training data is used to train the models, while the testing data is used to evaluate their performance on unseen data. Next, we apply the standard scaler to perform feature scaling. This process standardizes the numerical values so that all the features are on a similar scale, helping the machine learning model perform more effectively. We also examine the target variable distribution. The results show that approximately 72.5% of bookings were not cancelled, while 27.5% were cancelled. This helps us understand the balance of the dataset before the training models. Finally, after complete all the pre-processing step, the dataset was ready for machine learning modeling using a logistic regression, decision tree, and random forest algorithm. Thank you. That's all from me.
Assalamualaikum and hello. So my name is Arif Hijjaz bin Muhammad Shafi'i. So I will be explaining about the last part, which is machine learning models and evaluations. So first of all, we will go through our first model, which is logistic regressions. So for this model, we will train. We will run a prediction test. We will run an accuracy test, and then at last, we will run a confusion metric test. So first of all, we train a logistic regression model using the training datasets. The model learns the relationship between the input features and the target variables. So we use a scale data because logistic regression perform better with when features are standardized. So the reason why we train the model first, because we want the model to be used to predict the outcome for the test datasets, which it will be allowing us to evaluate its performance on unseen data. So the next, we will calculate the accuracy score to determine how many predictions were correctly classified by the logistic regression models. So after running the code here, it will show that it have like 77.36% accuracy. This will bring us to the next test, which is the confusion matrix. So the logistic regression coefficient matrix show that the model correctly classified 11,775 instances of class 0 and 1,745 instances of class 1. However, it incorrectly classified 896 class 0 instance as class 1 and failed to identify 3,060 class 1 instance, predicting them as class 0 instead. So this indicates that the model performed very well in recognizing class 0, but it struggled to detect class 1. And as a result, the model achieved an overall accuracy of 75.36%, but its ability to identify class 1 is relatively weak, with a recall of only 36%. This suggests that while the model is effective for a majority class, it missed a significant number of class 1 cases, making it less reliable when detecting class 1 is important. So after successfully train and run a few tests for the first model, we will go through the second model, which is the decision tree models. So we will do the same things. We will train, we will test the accuracy, and then we run the confusion matrix for this model also. So it shows here that the decision tree models successfully trained, and after running the accuracy test, we will get like 81.75% of accuracy. And then lastly, after running the confusion matrix for the decision trees, it showed that the model correctly classified 11,483 instances of class 0 and 2,804 instances of class 1. However, it's incorrectly classified 1,188 class 0 instances as class 1 and failed to identify 201 class 1 instances, predicting them as class 0 instances. So compared to the logistic regression models, the decision tree was better at detecting class 1 because it's correctly identified more positive case and missed fewer of them. So the improvement leads to a higher recall of 4 class 1s, making the models more balanced across both class. Okay, so last but not least, we will go through our last model, which is random forest models. Same as before, same as the logistic regression and also the decision tree models. We will train this model and also run a few tests, which is accuracy test, and then the coefficient matrix. So for the code right here, it will show that the random forest model is successfully trained, and then after running the accuracy test, you can see that the random forest will have achieved 81.84%, and then last will be the coefficient matrix. So after run the coefficient matrix, it showed that the model correctly classified 12,080 instances of class 0 and 2,223 instances of class 1s. However, it's incorrectly classified 591 class 0 instance as class 1 and failed to identify 2,582 class instance, predicting them as class 0 instead. So this model demonstrates excellent performance in recognizing class 0, achieving the highest number of correct class 0 predictions and the lowest number of false positive among 3 models. However, it still struggled to detect class 1s, missing a considerable number of class 1 cases. So next we will run a model comparisons between these 3 models, which is the logistic regressions, decision tree and random forest model. So to compare the performance of the 3 machine learning models, the accuracy scores were collected and stored in the data frames. The results show the logistic regression achieved an accuracy of 77.36%, decision tree achieved 81.75%, and random forest achieved 81.84%. These values were then visualized using a line chart to make a comparison easier to interpret. So based on the result, random forest produced the high accuracy, which is 81.84, making it the best performing model among the 3, and the decision tree performed almost as well with an accuracy of 81.75%, while logistic regression scored the lowest accuracy at 77.36. The graph clearly illustrate the improvement in performance from the regressions to the 3 base models. Overall, the comparisons that assemble learning methods such as random forest are more effective for these datasets because they can capture complex patterns and relationship within the data. Therefore, random forest were selected as the final models due to its superior predictive performance and high accuracy score. So to better understand which factor influence the prediction of those models, a feature importance analysis was performed. So features importance measure how much each variables contributes to the model decision making process. The features were ranked according to their importance score, with highest value indicate a greater impact on the predicting outcome. So the results show that lead time were the most influential features with an importance of 0.137740, and then it followed by market segments, country, total or special requests, required car parking space, agent, deposit types, previous cancellation, ADR, customer types, total cost, booking change, arrival date, years, distribution channels, and at last will be total night. The feature importance charts visually highlight the top 15 predictors used by the random forest models. From the analysis that we have done, it can be concluded that booking related factors such as lead times, market segment, customer location, special requests, and parking requirement have the strongest influentials on the predictions outcomes. So understanding these key variables help explain how the models makes decisions and provide value insights into the factors most associated with the target variables. So as the final conclusion and actionable insights, so this project successfully developed and evaluates 3 machine learning models, which is logistic regressions, decision tree, and random forest. to predict hotel booking cancellation. So based on the evaluation results, the random forest model achieved the highest accuracy, and the logistic relations have the lowest accuracy, which is 77.36. Therefore, random forest was selected as the best performance model for these datasets due to its super predictive capability and ability to capture complex relationship within the data. So the feature importance analysis revealed that lead time, market segments, country, total special requests, and required parking space were among the most influential factors affecting booking cancellation. So this indicates the customer booking behavior, booking characteristics, and the market relative factor play a major roles in determining whether a reservation is likely to be cancelled. So in particular, customers who book far in the advance tend to have a higher likelihood of cancellations, while booking attributes such as deposit type and special requests also contribute significantly to predicting outcome. So there's also a few actionable insights. So based on the findings, several business recommendations can be made. First, hotels should consider implementing and encouraging deposit-based booking policies, as a deposit types was identified as an important predictor of cancellations. Second, customer with long lead times can be targeted with reminder emails, confirmation message, special offers to reduce cancellation risk. Third, marketing and pricing strategy can be customized according to different market segments, allowing the hotel to focus on customer groups that generates more reliable bookings. Additionally, understanding the seasonal booking patterns can help the hotel optimize room pricings, promotional campaign during low demand periods, and finally, customer retention initiatives should focus on valuable customer segments identified through the analysis. It's helped to improve booking stability and overall revenue performance. So overall, the machine learning approach proved effective in predicting hotel booking cancellation and provide a valuable insight that can support data-driven decision makings. It also helped to reduce revenue loss from cancellations, and also at last, it also improved the hotel operational planning. So that's all from us. So before I end our explanation for this project, it will also show here that we have saved the final process data, and then we have successfully complete our project. So that's all from us. Thank you.